critical flow calculations in free surface flow with irregular cross-section. How to calculate the critical flow condition in free surface flow on canals with irregular cross-section? How to conduct these calculations? What basic principle and concept should we use? By definition, the specific energy is the total head using the local bed elevation as datum. Big E, specific energy, being the total head minus the bed elevation. Assuming hydrostatic pressure distribution in an open channel, we obtain this expression E equal d cos theta plus v squared over 2g, with d the water depth, v the velocity, and theta the angle between the channel bed and the horizontal. For a constant discharge, the relationship between specific energy and water depth shows this particular shape illustrated here with the specific energy on the horizontal axis and the water depth on the vertical axis. A key feature of this relationship is the existence of a minimum in specific energy, which correspond to critical flow conditions, denoted as the water depth d being equal to dc. So, by definition, critical flow conditions occur when the differentiation or the derivative of the specific energy with respect to the water depth for a constant discharge equals 0. That is, we obtain a relationship such as cos theta minus q squared over g a cubed times the derivative of the cross-section area with the water depth equals 0. Now, if we look at this sketch, any small increase delta d in water depth will lead to an increase in cross-section area delta A equal to B times delta D. Thus, we obtain for a flat channel, assuming cos theta equal 1, a relationship 1 minus q squared over g a cubed over b equals 0 as the critical flow conditions. We note that this relationship might be rewritten as v over square root of g times a over b equal 1, which is somehow equivalent to a Freud number. How to solve this relationship? It can be solved by trial and error, as illustrated on the table on the top right, where for various water depths, we calculate the free surface width, B, the cross-section area, A, and in turn, we can calculate the term A cubed over B on Q squared over G, and when these last two terms are equal, as on the bottom row, we obtain the critical flow conditions. It can also be solved graphically by plotting the expression Q squared over G on A cubed over B as a function of the water depth, as illustrated here. And when these two curves intersect, we have critical flow conditions. In summary, critical flow conditions in free surface flow correspond to minimum specific energy for a constant discharge. There is an exact solution in terms of the cross-section area A on free surface width B, which can be solved iteratively or graphically in terms of the critical flow depth. Relevant references, as well as a few more YouTube video movies. Thank you very much.